Okay, there we go. Alright guys, so y'all are group 5, which has been assigned to double replacement reactions. And so as you learn kind of in the introductory notes, double replacement is kind of all about the number 2. So what you're looking for in a double replacement reaction is you'll start off with 2 compounds that have 2 pieces swapping places. So 2 compounds, 2 swaps, okay? And so when we say like pieces of the compounds are going to have ions in them. So you're either going to be swapping the cations or swapping the anions, okay? And in doing so, by rearranging those parts or those atoms, you'll end up with 2 brand new compounds, okay? So the nice thing about double replacement reactions is that they can be broken up into kind of 3 parts. And the 3 types are written out for you word for word on your blue reference sheet. And so that's what I've got a screenshot right here. Now the catch is, the reactions are not bad if you will use the blue reference sheet to help you. But what you've got to convince your classmates to do is to actually read the rules on the blue reference sheet and just follow what they say. Oftentimes I've found in this unit is that students will try to do it in their heads without looking at the rules, and that doesn't go so well. So if you can get that across, kudos to you. All right, so what I'm going to do is I'm going to give you an example of kind of all 3 of the types. So that way, when you encounter one, you'll kind of know how to use the rules to handle it. And so what your goal is to basically start with reactants and be able to use the rules to predict kind of what product should form. All right, so we'll start in with type 1. And I'm going to literally write out the rule and then show you how what we're doing kind of corresponds with it. All right. So what it says is that an acid and a base, okay, yield salt and water. All right, so water and salt are going to be our products here, okay? And so first of all, we need to be able to know or recognize if we're dealing with an acid or a base. So we already know that with an acid, you should be looking for hydrogen in the front. And so with a base, what you're going to be looking for is hydroxide in the back or on kind of your second half of the molecule, okay? And so here's an example that we're going to do. We're going to start with phosphoric acid. So see, there's our H in the front. And we're going to react it with calcium hydroxide. So there's our hydroxide in the back, which lets us know that we're dealing with a base. Okay, so our rules say that when we do our double replacement, we should end up with a water and salt, okay? And so what I'm going to recommend, guys, is that when you're doing your double replacement, you can either choose to swap the first pieces, your cations, or the second pieces, your anions. And what I typically do, just to be consistent, is I tend to find myself kind of swapping the anions. So that means that hydroxide will come over and take phosphate's place, and that phosphate will come over and take hydroxide's place, okay? And so by doing so, we're going to get 2 new compounds. So now, instead of phosphate, we've got hydrogen and OH, okay? And so according to our rules, that tells us that that's going to combine to form water. So we'll just write in the formula for water, H2O, okay? Then our rule tells us that the second product we should form is a salt. Now a salt is just another name for an ionic compound, which means we've got a metal and then either a non-metal or some polyatomic ion as the second piece, okay? So in our second piece here, what we're left with is we've got calcium, and then its new anion will be phosphate, okay? Now the catch is, here's what most people will want to do. Most people just say, oh, okay, I've got 1 calcium and 1 phosphate, so that's what it should look like as my product. Not so, okay? So what you have to do is you have to kind of step to the side and actually create your product so that the charges balance. All right, so it's just like we did in last unit. So your calcium is 2+, your phosphate is 3-. So that means to get your balance formula, we're going to need 3 calciums and 2 phosphates. Okay, so there we have it. we've got our products, water, and our new salt. And so then the last thing that you go back and do is just to balance your overall equation by changing the coefficients. So since I've got 3 calciums on the right, I need 3 on the left. Since I've got 2 phosphates on the right, I need 2 on the left. And then if I look at my oxygens, I've got a total of 14 oxygens on the left, so I need 14 on the right. I've got 8 here, so that means I need 6 more here. And if I do that, then all my hydrogens balance out to where I've got 12 on each side. Okay, and again, you can kind of slow that down and balance it on your own. But that's the last step, is to balance your reaction overall. Okay, so there's our first type of double replacement. So now let's go on to rule 2, which says a salt and an acid yield a different salt and a different acid. Okay, here's our rule 2. So if we start with the salt, which again is just an ionic compound, so metal and nonmetal, and we combine it with an acid, we should create a new salt and a new acid. Okay, so let's just pretend that our salt is, maybe let's say lithium chloride. Okay, well, actually I'm going to change it up. Let's say it's lithium carbonate. No, I'm going to go with lithium chloride, and I'll just do a second example in a second. Okay, and let's say that our acid is, let's go with sulfuric acid today. All right, so we've got our salt, got our acid. And so now our rule says that we're going to form a new salt and a new acid once we've done double replacement. So I'm going to swap my anions here. Okay, some sulfate will come over and be with lithium. Chlorine will come over and be with hydrogen. All right, so my first compound, my new salt, I'm going to have lithium being with sulfate. And then in my new acid, I'm going to have hydrogen being with chlorine. Now again, just like before, you want to come to the side and do your charge balance before plugging in your new products. Okay, so for lithium sulfate, I need 2 lithiums to balance that out. Then for hydrochloric acid, it's just a 1-to-1 ratio. And then just like before, finish by balancing your equation overall with coefficients. All right. Now I am, while we're here, going to do one more example for kind of rule number 2, where you've got a salt and an acid giving a new salt and a new acid. Okay. So this time I'm going to do lithium carbonate plus hydrobromic acid. Okay. So again, do my double replacement where I swap anions. So bromine comes over to be with lithium. Carbonate comes over to be with hydrogen. And in doing so, I should get a new salt with lithium and bromine, and then a new acid between hydrogen and CO3 carbonate. So again, I've got to balance my charges. So lithium and bromine kind of balance out in a 1-to-1 ratio. Okay. And then HCO3, H is a +1, carbonate's a -2. So I'm going to need 2 hydrogens to go with my carbonate. All right. And so now the catch on this one, I want us to kind of focus in here on this for a second. So if we think back to our nomenclature unit, this is what we would call carbonic acid. Okay. Now I just want to make you aware of something. So if we go back and look at our rules for a second, you'll see that number 4 isn't really so much a rule. It's just kind of like, I guess, some extra info, if you will. And so right underneath rule number 4, it has this phrase. It says, if carbonic acid is made, it decomposes into water and carbon dioxide gas. Okay. So what that's telling us is that if one of our products happens to be carbonic acid, which it was, it will further decompose, or aka break down, into water and carbon dioxide gas. Okay, so we just want to kind of be aware of that. And so instead of leaving our product just as H2CO3, what we'll write instead is we'll acknowledge that it's further broken down into water and carbon dioxide. Okay, so we wouldn't leave this in here, but instead it would be, LiBr plus water plus carbon dioxide. Okay, and so that's just acknowledging that that compound is unstable in this case, and it's going to further decompose kind of on its own. And so from there, then we can go back and balance our equation as needed. Okay, but I won't do that just to save y'all some time. Okay, and so so just kind of be aware of that. So that happens for carbonic acid. It also happens for ammonium hydroxide. So that's NH4OH. And it happens for sulfurous, not sulfuric, but sulfurous acid, which is H2SO3. Okay, so just kind of be aware that those are out there and make sure to kind of show those to your classmates. All right, then last one, rule 3. As you'll see, it's very descriptive. A salt and a salt yield a salt and a salt. Okay, so number 3, basically, you're going to start with kind of 2 salts or 2 ionic compounds. And you're going to create 2 new salts. Okay, so let's just come up with one right quick. So let's say we've got copper 2 hydroxide. And let's say that we're going to react that with calcium chloride. So here we go. So we're going to do our swap again. So chlorine comes over to be with copper. Hydroxide comes over to be with calcium. So we're now going to have copper and chlorine for 1 salt. And then we're going to end up with calcium and hydroxide for our other salt. Okay. So again, we've got a charge balance. And so the catch is that if your metal can have more than 1 charge, you want to use the same charge that it had on the reactant side. So in the reactants, we can see that copper was copper 2 in this case, copper 2+. And so we'll want to use that same charge for copper in the products. All right, so this will be CuCl2. And then calcium over here is 2+, OH is -1. So that'll be CaOH. All right, then of course you'd go back and balance with your coefficients, and I think this one is actually already balanced. All right, so there you have it. Those are your 3 types of double replacement reactions. And so just so you're aware, this is a lesson that I will kind of continue talking about something called solubility rules. And that will kind of come into play on the 3rd type of double replacement reaction, but that's not something that you all are responsible for teaching. Okay. All right. Well, thank you very, very much for watching.